Okay, so today we're going to be talking about stoichiometry and balancing equations. So stoichiometry is calculating the amount of reactant needed for a reaction using mole ratios. So in simpler terms, we're trying to find the amount of reactant we need for a certain amount of product, or vice versa, because reactions can go forward and they can go backwards. So for this, we're going to need to start with a balanced equation. For those who don't remember, a mole is equal to 6.022, get that point in there, times 10 to the 23rd. And this can be in atoms, particles, or molecules. And the reason that we have the unit mole and this number is so large is because in laboratories we usually don't work with one atom or one molecule, we work with a bunch of them, and so we need the unit to be able to work with these things in the lab. So we're going to jump right into the first problem here. I'm just going to scroll the screen up a little bit. And so what we have here is N2 plus H2 reacts to form NH3, which is nitrogen plus hydrogen reacts to form ammonia. So what we need to do is to balance the equation. And to do this, we want to first look at the reactants. So our reactants are on the left side this time. And our products are on the right side. I'm putting R for reactants and P for products. So we see that we have 2 nitrogens and 2 hydrogens. So let's start with nitrogen and look at the product side. We have 1 nitrogen on this side. So we want to put a 2 coefficient out front. So that makes it 6 hydrogens on the product side. So we look back on the reactant side and we only have 2 hydrogens. So we want to put a 3 there, and that will give us 6. So now if we go back, we have 2 nitrogens on both sides and 6 hydrogens on both sides. So there we have a balanced equation. So now what we're going to do is we're going to take this balanced equation and we're going to do some stoichiometry. What we're going to try to do is we're going to try to get from this hydrogen and we're going to go to the ammonium or the products. So we're going to go from moles of hydrogen and we're going to try to get to atoms of ammonia to practice our mole skills and our mole ratios. Okay, so what I've written out here is 3 moles of hydrogen over 1. So this is what our starting point is. So then we want to multiply to get rid of units. And how we're going to do this is what you want to start with is whichever unit is on the top or bottom that you begin with, you want to put it on the opposite side. So since this is on the top, we're going to put it on the bottom. So I'm going to put moles of hydrogen on the bottom. And then what we want to do on the top is what we're headed towards. So we're headed towards ammonia. So we want to put moles of ammonia on the top. So then we have the moles of ammonium on top. So then what that's going to do is cancel out the moles of hydrogen. And then what we want to multiply by is we want to put moles of ammonia on bottom, and then we're going to put on the top atoms of ammonia. Okay, so now we can fill in those blanks. So we have 3 moles of hydrogen, 2 moles of ammonia in there. And then in 1 mole of ammonia, we have 6.022 times 10 to the 23rd, like we discussed what 1 mole equals at the beginning. So then all our units cancel, and we're left with atoms of ammonia. And then if you do all the calculations for that, your answer should come to 1.2044 times 10 to the 24th. So I wrote in blue the 1.2044 times 10 to the 24th atoms of ammonia, and that is your answer. So just remember to balance your equations and then use your mole ratios to do stoichiometry correctly.